it's time to get out the garage gear and replace the front wheel bearings on the Mercedes-Benz 300SL R129. I'm going to replace the inner seal, the inner bearings, and the outer bearings. I bought a kit that included the inner grease seal, inner bearing and race, outer bearing and race, new locking bolt, radiostatic doohickey, and the end cap that didn't fit anyway. The bearings have two parts. There's an outer race, and then there's an inner section that holds the actual roller bearings themselves. Now, these roller bearings ride inside a smooth steel ring that's called a race. The roller bearings look like small steel drums, and they're set in this race at an angle to create sort of a cone shape, and that is why they're known as tapered roller bearings. This hub cutaway shows how tightly the bearings will fit in there once they're installed. They're so tight that in order to make the races fit better, I'm going to put them in a bag and put them on top of the mint chocolate chip for a couple hours so that they'll shrink from the cold. I then jacked up the car, set my jack stands in the appropriate spots, and proceeded to take both front wheels off. I always like to place the wheel under the rocker panel for an extra margin of safety. To get to the bearings, I have to remove the caliper first, which means removing two 19mm bolts at the back, taking out the brake pads and sensors, and also removing this disc rotor. There's an end grease cap that lets us get at the holding nut. I pried the grease cap cover off with a flat blade screwdriver, work around the rim of it slowly, and then use a large slip joint plier to pull the cap off the rest of the way. There's a lot of old grease around the clamping nut, and I want to clean that all away so that I can get at the locking bolt, which is a 5mm hex cap screw. I'll start by removing the brake pads, driving out these pins with a drift. And then we're going to remove the caliper after we get these pads out. Unplug the pad wear indicators. Gently pull them out of the way. There we go. And these are pretty new pads, so there's not a lot of pushback. But what we're going to try to do is just kind of push a little bit on them to retract those pistons a little so that we will be able to more likely just kind of pry these out a little bit, work them top and bottom, and they should just work their way out. There we go. And do that for both pads. I'm going to take the inner one out now, but we'll work on the outer ones. The lower and upper bolts that hold the caliper on are 19mm, and you've got to reach the wrench around behind the hub carrier in order to get at them. With the mounting bolts removed, it's time to lift the caliper up and out of the way. Don't suspend it by the hose, put it on something solid so it doesn't swing. I'm going to use a 5mm hex socket to release the clamping bolt that holds that collar nut. Next, a wide jaw adjustable wrench will break loose that clamping collar nut. I can then spin it off by hand and get ready to remove the hub. We're going to leave this 5mm hex bolt in place for now. The clamping bolt has numbers and letters stamped on one side, but it's very smooth and polished on the side that faces the thrust washer. The thrust washer has a small channel groove that faces the clamping nut. We have to make sure that this faces that nut when we reassemble it. With hands at 3 and 9 o'clock, you can wiggle the disc rotor and pull off the outer bearings. With more wiggling and tugging, the hub and the disc rotor will come off the spindle. By removing the 5mm hex bolt now, we can pull that disc rotor up and off of the hub assembly. We'll just set that aside, and there is our amazing Mercedes front hub. The back of this hub is so corroded that I'm going to use this rotary tool with a grinding stone in order to clear the rear grease seal. That way I can use a punch and a hammer to drive it out. I've managed to drive both the grease seal and the inner bearings out, complete with their old grease. Next, I'm using the punch and the hammer to drive out the inner bearing race. You can actually hear it change sound as the seal starts to come out of the back. Now, what I want you to see up close here, if you can, see this is the inner bearing race, and then this is the shoulder inside the hub that's going to depend on. Now, I've already opened a gap up here by driving on it with the punch, and that's what I'm going to do. I'm going to work from the other side, put the punch in from this side, and continue to drive that out, going around in a circular fashion, and then I'll flip this over, and I will work on the race for the outer bearings, and that's going to come out there. What it is, that's what it looks like when it finally comes out. So there's our outer bearing race, just like the inner one, just a little smaller. It also has a shoulder inside, a ridge that it's going to sit on when we drive the new ones in. I want to get this really clean. We want to put this inner, smaller diameter part of the race into the hub facing downwards. Now this is a set of bearing and seal drivers. It has a post that you attach to one of the discs, and then you can use a hammer on it. These various discs come in different sizes. I'm using the 2.325 inch one. Tightening it with the bolt. This will totally cover the outer bearing race but still fit inside the circumference of the hub. The sound of the strikes actually changes pitch when it's actually seated. Driving the outer bearing race in is going to be the same situation. Just place it in with the small diameter facing the hub. You'll know it's properly seated when it comes up flush to the edge of the hub, just to the edge there. Be sure to use a grease that is rated GCLB. Place a blob of grease on your palm and then use a scraping, stroking motion to firmly press that grease between the bearing rollers. This is sort of the secret lodge handshake of auto mechanics that shows how you really know about wheel bearings. Whatever technique that you use, just make sure you cram lots of grease in there. It should actually look sort of like a greased donut by the time that you're done. Alternately, you could get a bearing packing machine like this. I bought this one online. You basically fill it with grease, then there's a plunger piston that you place the bearing on, and then press down with a tremendous amount of force to force the grease up through the bearing rollers. It puts lots of grease inside, but I like to spread some more around the outer part of the rollers as well. Place the inner bearings into the inner race on the inner part of the hub. Now, we don't really want or need grease on the center part, so once we've got it in the hub here, I'm just going to use a paper towel and clean that out. This is the part that will sit on the spindle. We're going to get that nice and cleaned out. We really want it just on those rollers and definitely in the race. Next, place the grease seal over the top of it, and again, we're going to use our seal and bearing driver set to put that in place. And when you are finished putting the rear seal on, it should look something like this. Notice there's no grease in here. It's all trapped inside the seal, and the seal is flush with the back of the hub assembly. We've cleaned the grease off the spindle and are now ready to place the hub with the new inner bearings directly onto it. Good firm press, and then the outer bearings get put onto the spindle and lift and wiggle the hub so that they line and seat on those outer bearings. Next up is our triangular shaped thrust washer, I'm going to slip that right on the end. Next up is our clamping end nut, and as we mentioned earlier, one side has stampings on it, numbers and letters, and the other side is very smooth and shiny. So the smooth and shiny part, we want to face that thrust washer, and we're going to make sure that we put our clamping bolt through. This is that little 5mm hex head nut bolt. Just get it started. Before placing the disc rotor back on, I'm going to put a little anti-seize grease on the face flange of the hub. Then comes the brake rotor, line it up with the holes in the posts, and it should slip right on. We're going to attach it firmly with the 5mm bolt and ratchet it on there pretty snug. Directly across from that bolt, I'm going to thread in one of the lug bolts and snug that down tight too. I don't want the rotor to wiggle for this next step. We're going to apply a dial indicator to the end of the hub and check the bearing run out. There's a magnetic base that attaches, and then a series of rods and connectors to attach this digital version of a dial indicator. Now please check your shop manual for the actual specifications, as they do vary by model and year. The crescent wrench allows us to snug down and loosen up the nut as needed to make sure the end play is correct. Pushing and pulling the rotor is going to demonstrate how much end play there is in the bearing. We're going to zero the machine and then gripping the rotor, move it in and out, trying to minimize how much we rotate the disc actually. Too tight. Using the wide-jawed crescent wrench, we can loosen and tighten the nut to get it within specification on how much end play there is. Once we're confident that we have our end spec set correctly, we're going to remove the dial indicator gently, and then we're going to tighten the clamping bolt with our 5mm hex. It's been my experience that the Mercedes tolerances are very tight. Next, I'm installing the little radiostatic doohickey that goes on the end of the spindle. Next, we want to place some grease inside this grease end cap. I'm going to take some of that high-speed synthetic grease. I'm going to put it mostly around the perimeter here so that it's going to come right up against the bearing. The grease itself, it's not only a lubricant, but it also helps to seal against moisture and brake dust and dirt and all those other things that are very bad for your bearings that occur far too regularly. With the end cap filled with grease, just press it directly on the hub and then gently with a rubber mallet tap around it until it's fully seated. I'm using a little blue thread locker on the mounting bolts for the caliper because, yes, we're almost done. It's time to put everything back together just the way it came off. We're going to remount the caliper, place the brake pads back in, putting the holding pins back in, the anti-chatter springs, and make sure you put the brake pad wear sensor cables back in and plug them in firmly. It's time to remount the wheels and get the car down off the jack stands and ready to drive. I always recommend starting the bolts by hand and then lowering the car to the ground before using a torque wrench, not an air impact gun, to set the correct tightness for all of your lug bolts. And because you've had the car with the brake pads off, make sure that you pump the brake pedal to reset them before you start the engine or try to drive away. Major funding for this program was made possible by
subscribers like you.
Subscribers like me?
Well, if they subscribe, they do.
Oh, that makes sense.